Welcome. In this video lecture, I'm going to talk about the distribution of SKUs techniques. So those are XYZ as well as ABC, which we are going to discuss in this lecture. So XYZ basically classify the stock keeping unit based on the variability in the demand. Okay. If the variability in the demand is less, we can classify it as X. If the variability of the demand is too much, we can classify into Z. If it is a moderate level, then we can classify into the Y. So basically, XYZ classification is based on the variability in the demand, whereas the ABC classification is based on the revenue value, okay, or a dollar value. Based on that, we can classify it into the ABC. So the product having the highest revenue or the dollar value, it can be classified as A. Then if it is having the lowest dollar value, then it can be classified as C. Moderate, it can be classified as B. Okay. So we are going to discuss these two techniques with the help of Python. So we will see how we can classify the real time, you can say a retail data set into XYZ classification as well as the ABC classification. Okay, so the data set which I am using, you can download from the Kaggle, which is the online retailer data set. This, which is basically a UK based retail company's data. Okay, so it is basically available from December 2009 to 2011, but I am going to use the data set of December 2010 to 2011's data, right? So 1 year data. So the data set is look like this one. So I am using this particular data, which is basically December 2010 to onward, which is basically December 2000 until 11, right? So we have this data set. So using this data set, I am going to classify the products, which is basically the stock code. So first of all, in order to classify, we are going to read the data set. And before reading the data set, we need the required libraries. So I have import the required libraries, which is pandas as well as the date time, okay, module from the Python. And then I am reading the CSV file. Okay, so using this R code out of this string is basically when there is a escalane marks. Okay, so we can use this R command in order to read it properly. Okay, if you are not using this one, then it is also okay, but sometimes it will may create the problem. But right now we have given the path where this data set is available. Okay, and after reading this data frame, okay, using the pandas, okay, so I am viewing this data set, the first 5 rows of this data set. As we can see that we have the invoice number, we have the stock code, we have the description of the product, okay, quantity, invoice date, unit price, customer ID, and country, right? So in order to perform the XYZ classification as well as ABC classification, we need to pre-process the data. Okay. So for XYZ classification, there is no need to have the invoice number as well as the description, as well as the customer ID, as well as the country, because we are going to classify based on their stock code. Stock code means we are going to classify based on the SKU or the product. So that's why we are going to remove these columns which are not required. So how we can do that? We can use the function called drop. So df.drop. So I'm removing the column name, okay, invoice number. So that is this one. Then I am removing description, customer ID, as well as country. So after that, we can view the first 5 rows of the data. So now you can see that. So in df2 variable, we have these 4 variables data set. Okay, the next thing what I am doing is, instead of performing the XYZ classification on the quantity, which is basically the sales quantity, okay, or you can say the demand of the product, what I am going to do is I'm going to classify XYZ classification based on the revenue. So that means first of all I need to calculate the revenue. Okay, so that means variation in the revenue. So how can I calculate the revenue column? By multiplying the unit price with the quantity. Okay, so and I'm going to create a new column with the name of revenue. So how we can do that? Because this data set is available in df underscore 2. So I am saying df underscore 2 create in this data frame the variable name revenue. So this is the name of the variable, which is the revenue, is equal to how you can create this column by multiplying these two columns. Okay, one is the quantity, another is a unit price. After multiplying it, so it will create a new column with the name revenue, and then we are viewing the data set. Now you can see that there is a another column with the revenue. The next thing is we need to deal with this date and time format. Okay, so first of all, what we are going to do is we are going to convert this date into the date and time format, because right now by default the pandas is going to consider as a string type or an object type. Okay, so how can we know that what kind, whether the pandas have taken it as a date and time, or whether it has taken other type of the data type? So we can check this one with the help of df underscore 2, the variable in which we have this data set. Okay, dot info. So if we run this one, we can see that the number of data entries we have, the number of variables we have in the df2. And if we can see this invoice, this is considering as the d type is the object type, which is basically considering as a you can say string type, right? So we need to convert this variable into the date and time, right? So how we can do that? We can use one of the function in the pandas, which is to underscore date time. So we are going to use pd dot to underscore date time. Okay, which variable we want to convert into the date and time, that is invoice data. Okay, and we are storing in the same variable. Okay, so basically we are replacing it. And then if I am going to check this info, now you can see that earlier the variable was object type, now the variable is date and time format. Okay, now I am viewing this data set. So as you can see that earlier it was seeing look like this way, which is with the help of escape you can say symbol. Now it is look like this date and time format. So what I need is, because I am going to calculate the variation of every SKU based on the monthly basis. So what I am going to do is I am going to separate from this date and time the year as well as the month. Okay, so how we can do that? With the help of function called date time index. Okay, so pd dot date time index, and then the name of the variable, which is the invoice data. So we are saying that extract from here is the year, so it will automatically extracting this date. But remember that before reading this data set, you must have this data set date and time must be the US based data format. Okay, if you set it as the Asian, especially like the India or Pakistan, so it will may create certain problems. So make sure your date and time format must have the American style. Okay, so you can check this one with the help of this one. So is it a Pakistan or the US based, right? So make sure it must be having the date and time format the US based. Okay, otherwise it will create the problem. So let me change to US. Okay, like this one. Okay, date and time format, as you can see. Okay, or let me change all the one. Okay, if I go to again more numbers, so then date and time format, and then this one. Okay, this one, so date as well as the time. So select this one. Now you can see it is changed. Okay, so I'm saving this one. Now once again I am going to read this data set, otherwise it may create the problem if I am not, because the earlier the date and time format was the I have selected the Pakistan. Okay. So let me read again. Okay. Uh, this one. Okay, just I am rerunning those codes. Now, if I run this one, so with the help of this one, I am basically extracting the year, and with the help of this one, I am extracting the month. Okay, so this is creating the problem. Like right now it's month, but it is saying month one. Okay, so that is basically creating the problem. So let me recheck it again, because if you can see that the year 2010 we have the month is not one, it is starting from 12. Okay, so let me recheck this one. Okay, that is basically creating the problem. So might be I need to, okay, because it is automatically changing when I'm closing it. So change to United States. This one, save it. Okay, let's rerun it. Let me rerun this one. No, it's look like okay. Okay, rerun this one too. Okay, now if I rerun it, no, it's okay. Okay, as you can see that now the month is 12. Now it is exactly fine. Okay. So once we have extracted the year as well as the month, okay, after that, what I am going to do is I am basically doing the grouping. Okay, so basically I'm creating another data frame which is df3. Okay, what I'm going to do is basically I'm going to take the sum of every SKU on a monthly basis. Okay, then basically I am creating a new data frame. So for that I am saying df2, that is we have this particular data frame. I am saying group by with respect to the stock code, which is basically the SKU, year and month, and take the sum with respect to the revenue variable, okay, which we have calculated. Take the sum, and then I am saying convert this one into a data frame, and then reset the index, which is 0, 1, 2. Okay, take it as this index. Okay, so if we run this one, now we have this new data frame tf3. Now what I am going to do is I'm going to combine these 2 months. Okay, basically with the help of this one I am creating month and date. Okay, so how can I do that? This with the help of this one, basically I am taking the year and then combining plus with underscore dash plus month. Okay, so basically with the help of this one, I am creating this new variable. Okay. Now what I'm going to do is basically this is you can say the long data format. I'm going to change it into the width wise, or you can say basically wide format perspective. So how can I do that? Basically I can use the pivot function. So that is basically I'm saying df underscore 3 pivot on index. Basically I am saying stock code is going to consider as an index, and the columns are basically the year month, that is this one column are the year month. Okay, and the values you are going to put is the revenue variable. Okay, this is again I am saying the reindex, which is take as integer from 0 to onward. Fill NA 0 mean if there is a missing value, fill it with 0. Okay, so if we run this one, now you can see that this long data set is changed into the width wise. So as you can see that we have every product. Okay, and against every product we have the revenue. Okay, which is basically against every month. Okay, this is December 2012, this is January 2011, February, March, up to we have December 2011. Okay, So once we have this data set, now we can perform the classification. So in order to classify, what we are going to do is we are going to first of all calculate the total sales. Okay, that is based on the revenue, the average monthly sales, as well as the standard deviation of the sale. So first of all, we are going to calculate the total sale. Okay, that is basically we are going to calculate for every, basically, you can say that product wise or the SKU wise or the stock code wise. So how can I do that? Basically, I am creating a new function in this df3, okay, data frame, and then I am saying that with the help of this one, that sum all 13 basically columns. So what 13, which is from 1 to 13. So we have the index over here is 0, so it is going to start from this one, 12 December 2010 to this time. Okay, so basically it is going to sum up these all numbers. So as we know that 1 to 13 mean sum these 12 numbers. Okay, similarly sum these 12 numbers, right? So with the help of this one, basically we are selecting those column, and then I am saying that what you are going to do with these 12 columns, sum it up. X is equal to 1 means column wise. Okay, so we are summing it based on that. We basically we are calculating the you can say sum of sales. Okay, that what we are doing it, right? So once we have calculated the total sales, that is basically this one. Okay, and we have created a new variable. Now what we are going to do is we need to calculate the average monthly sale as well as standard deviation. So for that, first of all, as we know that how many number of columns we have, this is basically we have the uh, 13 columns. Okay, because 12 and 1 month is this one 13. So you can check another way. What I'm going to do is I'm using the function length of df3 data frame of the columns. So if I run this one, you can see that we will get 15. One is stock code. This is not going to be considered because it's index. So this is a column stock code. We have 13, and then this is 1. So total we have the 15 columns. If I run this one, so we have 15. But in order to get the monthly average, we need to divide it with 13 because these are the 13 months we have. So that's why what I am going to do is in order to take the average month, so I am saying df underscore 3 total sales. Okay, that is this total sales variable divided by 13 in order to get the average sales per month. And then I am saying create another variable which is called as average underscore sale. Basically that is a new column, and I am viewing the first 5 rows. This is the average sales. Okay, now it's a monthly average sale. Similarly, we are going to calculate the standard deviation. Okay, in order to get the variation. So that is standard deviation with respect to column wise. Okay, so then I have created another column which is a standard deviation. So we have calculated the total sales, and based using that so sale we have calculated the average as well as we have calculated the standard deviation. Now, as we know that in order to perform the XYZ classification, we need to calculate the coefficient of variation. So how we can calculate the coefficient of variation? Simply, we can say that the standard deviation column. Okay, so df underscore 3, that is a standard deviation column divided by the average column. So divided by this average sale is going to be saved another column, or you can say variable, which is cv, which is coefficient of variation. And then I am viewing that data set. Now we have this cv, coefficient of variation column. So now based on this column, or you can say based on the value of coefficient of variation, we are going to classify this stock keeping unit, which is a stock code. How we can do that? The rules are, if the coefficient of variation is less than or equal to zero point 0.5, so that means lesser the coefficient of variation is indicating the lesser variation in the demand of the product. Okay, so that means more stable demand forecast, so we can classify it into x. But if the coefficient of variation is greater than 1, there is a huge uncertainty in the demand or the sales of that particular product. So we can classify it into Z. But if the coefficient of variation is between zero point 0.5 to 1, we can classify it into Y. So how we can do that? What I have done is I have basically developed a function called XYZ underscore classification, and I am going to give one argument which is X. So I am saying if that X, okay, which means if this coefficient of variation, this column, is the value of over here is less than zero point 0.5, okay, return it as X, okay, being classified it as X. Else if the value of X is greater than or equal to zero point 0.5 or but less than or equal to 1, classify it to Y, otherwise classified it to Z. Now I'm applying this function on on that data set. So what I am going to do is I am saying that create a column XYZ and then use this variable which is CV variable and dot apply what apply this function which I have created earlier, okay, and apply this criteria which I have defined within this function, and then I am saying return the first 15 rows, okay. Now if you can go at the end of this data set, now we can see there is a XYZ classification. So this particular SKU is classified as X. So this SKU is classified as Y. This particular SKU is classified as Y. Similarly, we have Z. So basically, we have classified every SKU based on the coefficient of the variation as XYZ. Okay, now if we move towards the ABC classification, so what I am going to do is I am going to use the same D3 dataset. Okay, that is this one, this variable. Okay, in which we have basically let me this one. Okay, in which we have stock, year, month, as well as the revenue. Okay, um, what I am going to do is in order to perform the ABC classification, I am going to create another basically data frame which is df underscore 4, and I am saying that in the data frame of df underscore 3 group by the function with the help of stock code, which mean every SKUs, and then I'm using the aggregate function. So basically I am summing the total sales against every SKUs. Okay, so against every SKUs, whatever the sale is, we are going to sum up that one. So aggregate, and then I am saying total revenue variable. Okay, and then we are saying total sales comma sum. So we are going to basically sum it up. So as you can see that the earlier it was we were considering as uh, over here is the revenue, right? In D3. So over here, I am basically summing it up, okay? And then what I am going to do is basically I am sorting it with respect to the total revenue in descending order wise, mean take the largest value at the first and then the next largest and the next largest and so on, okay? So basically we have arranged the data set into the descending order wise, and then what I'm going to do is I'm going to perform certain operations on this total revenue. So in order to perform the ABC classification, we need the percentage of every SKUs, okay, with respect to the total revenue. So what I'm going to do is first of all, I'm going to compute the cumulative sum variable, okay. What the meaning of cumulative sum is basically that is this is going to be as it is number, then this plus this, then the sum of that one is going to be sum of this one, okay. So we are going to take the sum, okay. So first of all we are calculating the cumulative sum function with the help of against this total revenue with the help of this cumulative sum function, and then the second column I am basically calculating revenue all, basically that means sum of this particular variable, which is a total revenue. So this is a sum. And then in the next column, which is basically I'm giving the name of SKU, revenue percentage. Basically, that is a proportion. So what I am doing is basically I am dividing this total revenue value with the total sum. Okay, mean the sum, this number. And then after that I'm viewing this data set. Okay, so with the help of this one, we have seen this data set. Okay, till now we haven't classified because I have already done that one, and that's why you are seeing this one. But in order to classify is as ABC. So what I am going to do is I am classifying the product as A if the total revenue is 80%. If it is between 80 to 90, then it would be considered as B. If it is more than 90, okay, the remaining one is basically then the revenue is less than 10%, then it is going to be considered as C. So for that, again, I have created a function which is ABC classification, in which I am saying if the x is greater than 0 but less than or equal to 0.80, consider as A, okay, which mean I am talking about this particular column. Okay, similarly, if it is between 80 to 90, classified as B. If it is else, then classified it is as C. Then I am saying that create another basically column with the name of ABC. Okay, that is this ABC. And then I am saying apply this function on this variable, which is this SKU revenue underscore percentage, and apply this particular function. Okay, mean apply these condition on that variable. If we run this one, now you can see that we have certain you can say SKUs are classified as C. So this is tail. So let me take it as if I'm going to see the head. Okay, now you can see that some are A. Okay, similarly we have some are the ABC, right? So basically this is how you can apply the XYZ as well as the ABC classification. I hope you got the idea. So thank you so much. See you in the next video.